So this is an example of a math question that you may have seen, and I'm going to show you how I would solve it from a physics perspective, given the information that we have. Here's the picture. A car drives up a hill at a constant speed. So while the car is going up the hill, it's going 40 kilometers per hour. And then it gets to the top, turns around, and travels back down at 60 kilometers an hour. 60 kilometers per hour. And on first glance, you would say, well, that's pretty straightforward. It's just 50 kilometers per hour. But that's not exactly true. Average speed, remember what average speed is. VAV, that's average speed, is equal to the total distance. So delta x, I'm going to say total. So the total distance you traveled divided by the total time it took. Delta t total. Okay. So what we need to figure out is the total distance and the total time. Now we don't have either of those pieces of information. All we have is the average speeds. But basically what we can assume is that it's going to be delta x for the up plus the delta x for the down divided by the time it takes to go up plus the time it takes to go down, right? Now, a couple of things I do know. I do know that the distance up is going to exactly equal the distance down. So let's say this is the distance from here all the way to here. I'm just going to call it d. So I know that distance is the same for the top and for the bottom. So I can just call each one of those d. When I set up this equation, I can just say this is d plus d, right? And then now I just have to figure out the time taken. Well, in order to figure out the time it took, it's going to kind of depend on the speed, right? When it's going slower, the time's going to be longer. When it's going faster, down 60, the time's going to be faster. So let's look at this original equation again. We'll look at this equation, which is V equals delta x over delta t. This time I'm going to solve this. I'm going to rearrange this and solve it for t. So delta t equals delta x over speed, right? Delta t equals delta x over v. So now what I can say is, so let's look at the delta t for the up is equal to the distance to the up, we just called it d, and the speed for the up is going to be 40, right? So that's my expression. And then delta t down is equal to d for the down and then 60 for the speed. So you see, I don't know the distance, but I know it's d. So I'm just leaving the d in there. Now, when I go to substitute delta t up, I'm going to say d over 40 plus, and then this becomes d over 60. I've left out the units just to simplify the equation. Okay. Now, depending on your comfort with rearranging equations with fractions and fractions, you can do this in one step, or you might need a couple of steps. I'll draw it out a little. So the numerator becomes 2d, and the denominator, we're going to find a common denominator for our denominator. So it's going to be 60d plus 40d all over 40 times 60, right? 40 times 60. And then I'm going to invert and multiply. So this becomes 2d times, I'm going to invert this whole thing and multiply 40 times 60, and then divided by, I can divide this whole thing by, and it's 60d plus 40d, which is 100d. Okay, so now you can see that I've got a common factor of d in both the top and the bottom. So I'm actually going to cancel that out. I don't have to worry about d's. It didn't matter what the distance was because it's a common factor and it cancels out. So that helps. So then when I go and, let me put this over here, 2 times, so what's 40 times 60? It is 40 times 60 is 2,400 times 2 divided by 100 equals 48. So what we're solving for here is VAV equals 48 kilometers per hour, which is surprising, and it's less than you would have thought at 50. And let me just quickly put a sentence here. The average speed is 48 kilometers per hour. And the idea here, and what I want to get at here is speed is what we call this average speed is actually a time weighted average. It's this thing right here, what we said here. You take longer when you're going slower. So you spend more time traveling at 40 kilometers an hour and less time traveling at 60 kilometers an hour. So your average is sort of weighted on the side of the slower. So instead of being 50, it's slightly less than 50, 48 kilometers an hour. And this is how we arrived at that answer.